Hello students, and welcome to the unit analysis and conversion video. You're going to need a composition notebook, your pen or pencil, and a calculator. So the first couple of slides I'm just going to talk about why this is important and why we're doing this unit analysis. So if you are driving to Canada and all of a sudden you see a speed limit sign and it says 100 kilometers per hour. Yeah, exactly. We might think that's 100 miles per hour. But what you need to know is that kilometers is not the same as miles. So we have to be able to convert to miles per hour. So this might be one scenario that we might need to use unit analysis. Otherwise, if you did go 100 miles an hour, you might end up getting a very hefty speeding ticket. So why else would we be doing this? Well, not only driving to Canada, but maybe recipes. It calls for quarts, it calls for pints, but you have measuring spoons or cups that are in cups, not in quarts and pints. Maybe when you're buying products at the store, you want to know which store offers the best price per unit, or maybe you want to know which brand offers the best price per unit. Also, if you're taking chemistry or have been in chemistry, you will be working with changing units a lot, even in physics. Acceleration, you might do miles per hour to feet per second. You might change moles to grams and grams to moles. And in chemistry, they call that stoichiometry. So what happens when we use unit analysis? And this is where you might want to start taking some notes. So what happens when you divide a number by itself? So if I take 3 divided by 3, what do I get? You get a 1, not a 0, but a 1. Okay? And so you're thinking, well, I knew that. Yeah, you did. And we can all appreciate that. But I want to know then, when you divide a unit by itself, what happens? So say you take centimeters divided by centimeters. What happens? Well, guess what? The same thing happens. You get a 1. And this is what is so important about unit conversions and unit analysis. You have to be able to see that there are units that are going to be canceling out to make 1. So what is unit analysis? Another word is dimensional analysis or conversion factors. All that means the same thing. But what it is using the conversion factors and units to help us see the steps we need to perform and convert the units properly. We think about canceling or dividing units to help us. So if I were to give you just a general example, convert 6.25 inches to centimeters, you would probably go, okay, how do I get from inches to centimeters? Well, exactly right. That's what we need to know. So when I have the problem, I need to set it up just like this. So you're always going to start out using what you are given. So the 6.25 is what you are given. The second part of the problem is going to be using the conversion factors that you need. So in this case, the conversion factor I need is from inches to centimeters or centimeters to inches. So I know that 1 inch is equal to 2.45 centimeters. I also see that when we do unit analysis, we do cancel out those things, those units that we don't want anymore. So we don't want the inches anymore. So they're canceling out. And what we're left with is the centimeters, the desired unit that we wanted in the problem. This is how we're going to set up every single problem that we do today. So make sure that you follow along and do the examples as I have them, as I do require you to show work for these problems. All right, let's go ahead and talk about having a European recipe that calls for 5 pints of water. And you're thinking 5 pints of water, how much is that? How many cups is that going to be? Well, first of all, I always start my problem with what I'm given. So 5 cups 5 pints is what I'm given. And I need then the conversion factor. The conversion factor that I'm going to use is from pints to cups or cups to pints. I know that there are 2 cups in every 1 pint. Now I put the pint on the bottom, so the pint that's on top over here and the pint that's on the bottom over here can cancel out. We want them to cancel out. So they need to be in the opposite place, numerator, denominator. Then I look at the problem and I say, okay, this is simple math. Take 5 times 2 and divide by 1. 5 times 2 is 10. Divide by 1 is still 10. So I would need 10 cups of water. And that would be my answer. Okay, let's go ahead and do example number 2. What about if you were 16 years old right this second? How many seconds have passed since you were born? So we always start with what we're given, 16 years. And we do a conversion factor to get from years to seconds. Well, I know I can't go from years to seconds because I don't know how many seconds are in a year. But I can use more than one conversion factor. So we might use multiple conversion factors. In this case, I know that 1 year has 365 days. Okay, now I've gotten to days. Now what am I going to do? Well, now I need another conversion factor. I need to go from days to hours. Well, I know in 1 day, there's 24 hours. Okay. Now I'm going to go from hours to seconds. Oh, don't know hours to seconds, so I need another conversion factor. I'm going to actually go from hours to minutes. So in 1 hour, there's 60 minutes. And then I'm going to need one more final conversion factor, which is 1 minute has 60 seconds. Okay, so sometimes you need one conversion factor, sometimes you need multiple conversion factors. But when we look at this, every single time we look at this, we should see that our units cancel. Years cancel with years. Days is on top, days on bottom. Those cancel. Hours in the numerator, hours in the denominator, they cancel. Minutes in the numerator, minutes in the denominator, they cancel. And what are we left with? We're left with seconds. That's what the question asked us. So we always want to end with what the question is asking us to get to. Now, this is multiply everything on top and divide it by everything that's on bottom. So if I multiply everything on top, I would get 504,576,000 seconds. And then on bottom, I'd get 1 times 1 times 1. So then it would be divided by 1, and anything divided by 1 is itself. So it just stays the same number of seconds. That's how many seconds you would be if you were exactly 16 years old. All right, let's do another example. Example number 3. You drive at 45 miles per hour. Okay, this time I start with miles per hour. That's where this sign, division sign, comes in, miles per hour. Okay, I'm going to need a conversion factor that is going to help us get from miles per hour to feet per second. All right, well, I need a conversion factor that goes from miles to feet first. And that conversion would be in 1 mile. Okay, notice I'm putting the miles in the denominator because that'll cancel with the miles in the numerator, is equal to 5,280 feet. Oh, and that's what we want. Our miles cancel and we have feet. But if I stopped right here at this problem and finished it out, I would have feet per hour. But the problem says I want feet per second. So we need another conversion factor that's going to get us from hours to seconds. All right, so we know that there are 60 minutes in an hour. Okay, I got to be careful here though, because hours are in the denominator. In order for an hour to cancel again, it would have to go in the numerator this time. So in 1 hour, there are 60 minutes. Okay, and now I want to take my minutes to seconds. So because the minutes are in the denominator, I want to put minutes in the numerator, and in 1 minute there are 60 seconds. So if you look at this problem, now my hour cancels with my hour in the numerator and denominator. My minute in the denominator cancels with my minute in my numerator, and I am left with seconds in the denominator. And that's what I want. I want feet per second. So I want feet in the denominator or in the numerator and seconds in the denominator. And that is what we have. All right, now to do this problem, you multiply everything across the top, you multiply everything across the bottom, and you divide. So 45 times 5,280 would give you 237,600 feet divided by 60 times 60 is 3,600 seconds. And when you divided those two numbers, you would end up with 66 feet per second. Okay, so that is an example of doing multiple conversions again in a problem. Now we're going to go back to our Canada question and find out exactly how many miles per hour 100 kilometers per hour are. Now notice in this case we only have to convert the miles and the kilometers. We do not have to convert the hours. They're going to stay the same. So you always start with what you're given, 100 kilometers per 1 hour. Okay, and you're going to need your conversion factor for kilometer to miles or miles to kilometers. And I happen to know that there are 1.609 kilometers in every 1 mile. And so now our kilometers are going to cancel and we will be left with miles per hour. Now just multiply the top times the top and the bottom times the bottom, and that will give us our answer. If we take 100 times 1, we get 100. If we take 1 times 1.609, we get 1.609. Now we divide those out, we will get 62 miles per hour. Hey, that's a lot different than 100 miles per hour, isn't it? Wow, you'd be going 40 miles over the speed limit. You'd probably get your license taken away at that rate. So anyway, this is another example of doing unit analysis. Please show your steps and show that your units are canceling. And then one last slide that you want to take notes on. Some of these you might already know, and if you know them, you don't need to write them down, but I will expect you to know these ones for a test. So 12 inches is 1 foot, you know that. 3 feet in a yard, you probably know that. 5,280 feet in a mile, that's probably something we know. These might be something that you might really want to write down because you're fairly new at knowing them. 1 inch is 2.54 centimeters. A mile is equal to 1.609 kilometers. 1 foot is equal to 0.3048 meters. You might know 16 ounces in a pound, and you might not know that one, but if you don't, go ahead and write that one down. And then some of these might be familiar to you as well. 1 gallon equals 4 quarts. 1 quart equals 2 pints. 2 pints equals 2 cups. And 1 cup equals 8 fluid ounces. Now, when I was in 8th grade, I learned this handy dandy trick from my facts teacher. Gallon I draw a gallon. And in that gallon, I have 4 quarts. This is just a visual for those of you that need the visual. It helped me, and I've never forgotten it since. In each quart, you have 2 pints. And in every pint, you have 2 little cups. And I hope that helps you maybe visualize those ones so you don't have to do as many of them in memorization. So that's all for now, folks. Have a great day.